Hey everybody, this is Mr. Ainsworth, and we are going to go over all the key elements that was on the pretest to get you guys ready for your big common assessment in Algebra 1. So here we go. Let's start with some inequalities here, solving and graphing. All right, the first thing we're going to do is I'm going to rewrite it over here. So 7 less than or equal to negative 11 minus a. Well, the first thing I want to do is isolate your variable here. So I notice that I see a negative 11 here, and the opposite of negative 11 is positive 11. So I'm going to add the opposite, okay? These cancel. I get 18. 18 less than or equal to negative a. I'm going to divide both sides by negative 1 because I want to cancel out the coefficient that's negative. I know that a negative divided by negative is a positive, right? So obviously that clears it right there. And I get negative 18, all right, is greater than or equal to a. I have to switch the inequality. Take a look closely. When you divide by a negative, you got to switch the inequality. Well, if negative 18 is greater than or equal to a, that means that a is less than or equal to negative 18. All right, so what does that mean? It means that all numbers are less than or equal to negative 18. See, so that includes negative 18, so it's going to be solid. And all numbers less than that lie to the left. All right, so you can always check. I always provide answers here. You can see all numbers less than or equal to 18 is the correct answer. All right, and that's how the game is played. Isolate the variable and remember the basics. Okay, so negative 10 less than n plus 9. I see plus 9, so I'm going to add the opposite, which is a negative 9. So if I add a negative plus a negative, I get a bigger negative. So negative 19 is less than n. And if negative 19 is less than n, that means that n has to be greater than negative 19. So you switch the order of the inequality. Why is that? Well, if 2 is less than 3, that means 3 is greater than 2. That's why. So you got to recall the basics here. If you want to switch the order of the inequality, then go for it. Just switch the inequality 2 to keep it a true statement. All right, so all numbers greater than negative 19 don't include negative 19, which is right here. This is negative 19. And they're to the right. All numbers greater than always lie to the right. All right, let's continue on. Okay, so 1 is less than or equal to negative 8 minus a. Well, once again, just like the previous one, I want to add the opposite. So let's do that. 1 plus 8 is 9. That's less than or equal to negative a. I divide by negative 1 to cancel out the negative coefficient. Notice that they cancel here. A negative divided by negative is a positive. And I get negative 9 is less than or equal to a. And if that's the case, a is greater than or equal to negative 9. Once again, you switch the inequality, the order of it. And if that's the case, all numbers greater than or equal to negative 9 include negative 9, which is right here. So you go closed. And all greater numbers lie to the right. That's it. Piece of cake, man. Okay, next one. Negative 220 is greater than negative 11n. So negative 11n is negative 11 times n. So I divide by negative 11. Keep in mind that I just divided by a negative, so I have to switch the inequality here. All right, so 11 times 20 is 220. So 220 divided by 11 must be 20. 22 divided by 11 is 2, right? But it has to end in a 0. So 20 is greater than n. And if that's the case, that means n is less than 20. So 20 is not a solution. We want all numbers less than 20. So we're going to express all these answers here. Again, 20 is a reference point. Just checking the solutions. They're right here. There we go. Whoa, what happened here? What happened? Hmm. If negative, what I do? 20. If 20 is greater than n, then n is less than 20. I don't see a mistake here. Let's see here. Oh, I forgot to switch the inequality right here. Duh, okay. So this is incorrect. All right, this is why checking your work is so important because I just made a silly mistake. I divided by a negative, so I switched the inequality. I didn't do that right there. This is the importance of checking your work. Even instructors make silly mistakes, as I just demonstrated right in front of you. So you switch the inequality when you divide by a negative. And now let me repeat what I said, and correctly this time. If 20 is less than n, that means n is greater than 20. All right? So 20 is not greater than 20, so it doesn't include 20. There's a reference point. So we're going to open here and to the right, or you can do it right on the number line. Okay? All numbers greater than 20 are like 21, 22, and so on. Now it looks good. Okay, so pay attention to detail. So negative 8v is greater than 8. Uh-oh, here we go again. Divide by a negative. So v is less than negative 1. Okay? And if v is less than negative 1, it doesn't include negative 1, so we go open here, and all numbers less than any number always lie to the left. Okay? Next one, we got 16n is less than or equal to negative 32. Divide both sides by 16. All right? And you get n is less than or equal. No need to switch there because we divided by a positive, not a negative. So it's different than number 5. All right? Less than or equal to negative 2. That includes negative 2. So we're going to go, closed here. All numbers less than that lie to the left. Okay? So those are some basics on the initial inequalities there. For compound inequalities, well, it takes a little bit more work. Okay, so let's get started here. So we got negative 8n is less than 24. We divide by negative 8, and we get n greater than negative 3. Or 4 plus n is less than or equal to negative 6. After subtracting negative 4, we get n is less than or equal to negative 10. And again, this is or, so I'm going to highlight that. So this is all numbers greater than negative 3 are to the right of 3. All numbers less than negative 10 lie to the left of 10. So x can be here or x can be here. All right, we're not looking for the intersection here, guys. This is an or statement. Not only that, these numbers there in the middle don't even make sense. If I pick negative 6, negative 8 times negative 6 is 48, which is not less than 24. So the numbers in the middle here are not solutions. Remember that. You can just test one and it fails on one of these inequalities. Now on this inequality here on the and statement, this is different. You got to satisfy both. So here we're looking for the intersection. So p minus 3 is less than or equal to negative 8. P minus 9 greater than or equal to negative 15. So we got to solve these. So let's add 3 and get p is less than or equal to negative 5. We add 9. We get p is greater than or equal to negative 6. And again, this is an and situation. So here you're looking for the overlap, or what's called the intersection. So here we go. So less than or equal to negative 5. Here's negative 5. Greater than or equal to negative 6. So here. And so the overlap, I'll put that in blue. So you got to be greater than negative 6 and less than or equal to negative 5. So these are both solid, sorry. So let me fix that. There we go. So here's the solution in blue. So you got to be in between these numbers here and including those numbers here. So let me just show you that. Number 8, here's the solution. Look at that. Between negative 5 and negative 6 and including those numbers. Okay, inclusively, as they say. All right, moving on. So here we have x minus 3 less than or equal to negative 8, or negative 4 plus x greater than or equal to 3. Let's add 3. X less than or equal to negative 5. Here, add 4. Why? Because it's opposite of negative 4. And get x is greater than or equal to 7. And again, this is an or statement, so you don't look for the intersection here. You can be either here or here, not both. So less than or equal to negative 5 is to the left of negative 5. And here's 7 right here. And if you're greater than or equal to negative 7, you're to the right. Okay? Okay. So on this one here, x greater than 3, divided by 3 is greater than or equal to negative 1. And v plus 7 is less than or equal to 17. So the very first thing we want to do here is do the inverse. If you want to cancel out a number that's being divided, you multiply. All right, 3 divided by 3 is 1. 1 times x is x, greater than or equal to negative 3. Here, after you subtract 7, you get v is less than 10. Okay, so you're looking for both. Here, you got to satisfy both. So if you're less than 10 and greater than or equal to negative 3, you lie between these values. So negative 3 is here, 10 is here. Those are the values. All right, and you got to be between those. So greater than or equal to negative 3, closed here. Less than 10, so it's open here. Any number in between. Okay? If you're greater than negative 3 and you're less than 10, you got to be between. X is any number between there. Okay, because 11 doesn't make sense. 11 plus 17 is 18, and 18 is not less than 17. So over here, these are not solutions to the right of 10. All right? Okay, moving on. So let's solve the equations. Let's distribute twice. So we have negative 192 is equal to negative 64 plus a negative 32n. Let's add the opposite here. Now, for those of you that like calculators, you could do this. There we go. You got to press the buttons right, though. Negative 192 plus 64. Look at this. Negative 128. I don't care if you use the technology, just use it properly. So negative 128 is equal to negative 32 times n. So notice that I said times. That's why you got to divide by negative 32. All right. So that's 1 there. So 1n is n. So n is equal to whatever this is, right? We know the negatives cancel. But what's 128 divided by 32? And I think it's 4, right? So we take 128 divided by 32. And look at this. You get 4. Look at that. Now, this next one here, you got to be careful. You got to distribute twice, and you got to distribute not 4, but negative 4. So be careful there. So we have negative 4x minus 4 times 1 is 4. And then here, a negative 4 times a negative 5x is a positive 20x. You better check your work here. You better distribute twice and check that second term, because that's where the mistakes are always made. Okay, so be careful there. Equals negative 84. Let me see, let's add like terms. This one and this one, 20x minus 4x is 16x. Add like terms. All right, minus 4 is equal to negative 84. Add the opposite. And you get 16x is equal to negative 80. 16x is 16 times x, right? The inverse is division, right? So divide by 16. If you don't know what that is, if you don't know it's negative 5, don't worry about it. Just enter it in. Take negative 80 divided by 16, and you should get negative 5. So x equals negative 5. There we go. On the back side, let's check out some literal equations. Now here we're solving for x. So solve each equation for the indicated variable. So we're going to solve for x. So let's do that here. So z is equal to y divided by x times m. The very first thing I'm going to do is get the variable out of the denominator. We don't want it there, guys, okay? So I'm going to multiply both sides by xm. You can do that. Believe it or not, you can multiply anything you want on both sides except 0. Anything divided by itself is 1 over here. So we have x times m times z equals y. And notice that I said times. Everything's being multiplied on the left, which means it calls for division here. So you divide both sides by mz, or m times z, and you get x is equal to y divided by m times z. Now, that's not the only way to do it. Okay, there's other ways to think about it. So if you don't like that way, just let me know, and I'll show you another way. Okay, on this one, here's x. We got to solve for x. And so what I think here is you got to cancel out the c. So I'm going to add the opposite. Opposite of c is negative c. These cancel out. And you get x is equal to r minus d minus c. R minus d, just read it, minus c. And they're all unlike. So you can't combine them and you're done. It's that simple. Okay, this next one's not too simple. Okay, so on this one here, we've got z equals y minus m times x. Okay, and you want to solve for x. So you got to get it out of the denominator. So the very first thing I'm going to do is multiply everything by x. I'm going to multiply all terms by x. And I get x times z is equal to y times x. No, I'm not going to do that. You could do it that way, but I choose differently. So let me switch gears here. So I'm going to subtract y. So we have z minus y is equal to negative m divided by x. Okay, next thing we're going to do is we're going to multiply both sides by x to get it out of the denominator. You don't want that, right? So x divided by x is 1. Here we get x times quantity z minus y is equal to negative m. Almost there. And because this is being multiplied by x here, I'm going to divide both sides by z minus y. Z minus y, divide. You notice those cancel out. And I get x is equal to negative m divided by z minus y. Now, is that the only way you could do that? The answer is no, because I started a different way initially, okay? But that's one way. Okay? That's one way. There's multiple ways to do this. Oh, God, we have the same type of deal right here. Okay, so on this one, same type of deal. I'm going to multiply both sides by x again. So m divided by x is equal to n minus p. So multiply both sides by x to get it out of the denominator there. Boom, look at that. So I've got m is equal to x. I'm going to switch the order here, times n minus p. Now notice I said times. So what we do is we divide by n minus p and we're done. Anything divided by itself is 1. So my answer, x here, is equal to m divided by n minus p. Okay, that's a heck of a motorcycle out there. All right. Next one. That's not a motorcycle, that's a scooter. Okay. Oh, well, it doesn't matter. Okay, solving for a here in this one. So here's a right here. Just find it. And add the opposite, add m. This one's totally simple. So these cancel and you get a is equal to p plus n plus m. And you're done. I solved for a right there. This one's a little bit more challenging. Solving for a, I got to add the opposite here. So subtract k. So I get negative a is equal to w minus v minus k. W minus v minus k. And now I got to divide everything by, or multiply everything by negative 1. Or divide everything by negative 1, which changes all the signs. Change all signs. So these cancel and you get a is equal to, change the sign here, w divided by negative 1 is negative w. Negative v divided by negative 1 is positive v. And negative k divided by negative 1 is positive k. Okay, now this is a video, just let me remind you. So if you need to rewind this, pause the video, rewind it, and listen to it again, all right? Figure it out, investigate it, think about it. All right. So on all these absolute value equations, we got 2 solutions here. So we're looking for 2. So the first thing I understand is that whatever's inside this absolute value, it's got to be 11 units from 0. So I know it has to be either 11 or negative 11. Okay? So n minus 6 could be 11 or n minus 6 could be equal to a negative 11. It doesn't matter. Okay, so add the opposite and solve both equations. You get n is equal to 17. Man, this video is going to be something because I'm competing against the scooter outside. Okay, negative 11 plus 6 is negative 5. So you're looking for two solutions here. Okay. Ooh. My son just came up and he's looking sharp. Okay, you got to tighten up your suspenders though. The phone doesn't help you tighten up suspenders. Okay, so let me go back to the video here. So on this next one here, let me get whatever's inside this absolute value here, using your common sense, it could be equal to 24. Absolute value of 24 is 24, and absolute value of negative 24 is 24 as well. So you have to figure out negative 8 plus 8b equals 24, and negative 8 plus 8b could be equal to negative 24, the opposite of that. Okay, so let's solve for here. Let's add the opposite. You got 8b equals 32. 8 times 4 is 32, so b is 4. Add the opposite here, and you get 8 times b is equal to negative 16 divided by 8. All right, and b is equal to negative 2. Why? Because 8 times negative 2 is negative 16. All right. Okay, same thing here, guys. Okay, same thing. So this 6k minus 2 could be 10 or it could be negative 10, right? So you got to be figuring out 6k minus 2 could be 10, or 6k minus 2 could be equal to negative 10. What values do you get? Well, let's add the opposite first, and you get 6k is equal to 12. 6 times 2 is 12, so k must be 2. Add the opposite again, so you get 6k is equal to negative 8. Ooh, you get a fraction here. Negative 8 divided by 6, or negative 4/3. A little bit more challenging here. All right, and last one here, whatever this is inside the parentheses, or excuse me, inside the absolute value, could be equal to 98. All right, absolute value of 98 is 98, or the absolute value of negative 98 is 98. So you have to solve 8 minus 10b is equal to 98, and 8 minus 10b is equal to negative 98. So let's add the opposite first, and you get negative 10b is equal to 90. Negative 10 times negative 9 equals 90, so b equals negative 9. Add the opposite again, and you get negative 10b is equal to negative 106. And yeah, that's right. Dividing by negative 10. Okay, b is a positive value here. And 106, that's a 10 and 6/10. All right, but that's 10 and 3/5. That's the same thing, 10 and 3/5 right here. All right. And that's how it's done, everybody. All right, that's a lot of concepts here that could really help you out if you master them on your first common assessment here in Algebra 1. So do your best. Remember, this is a video, so you can rewind and listen to anything you want. This is Mr. Ainsworth, and I'll see you tomorrow on your test day. Make yourself proud.